In physics, a wave is a disturbance that travels through space and matter, transferring energy from one place to another. It is important to note that waves transfer energy, not necessarily matter. Let's look at some examples. There is, of course, the wave of the hand. Other instances include ripples in water, sound waves that are created when a musical instrument is played. Say for example, when a flute is played, or a string is being pulled, or even a drum is slapped. These are mechanical waves as they need a medium to travel across. It means that they require some matter to travel through. These waves travel when molecules in the medium collide with each other, thus passing on energy. So, as seen in the above instances, sound waves are mechanical waves that move through matter, either through air, liquids or solids, and then vibrate our eardrums so we can hear. Similarly, you can drop a rock into a pond and see waves form in the water. Another instance of mechanical waves would be the seismic waves generated during earthquakes, as they travel through the earth as a medium. But not all waves need a medium to get through. Such waves, called electromagnetic waves, can travel through a vacuum. They travel through electric and magnetic fields that are generated by charged particles. Examples of electromagnetic waves include light, microwaves, radio waves and X-rays. Thus, we see that all waves can be categorized as either mechanical or electromagnetic. This is the most common classification of waves in physics. A mechanical wave is a wave that is an oscillation of matter and thus moves or transfers energy through a medium. Waves can travel across long distances, but the movement of the medium of transmission, the material, is limited. Mechanical waves transport energy. This energy moves in the same direction as the wave. It is important to note that mechanical waves can be generated only in media that have elasticity and inertia. A mechanical wave needs some kind of initial energy input. Once this initial energy is added, the waves move through the medium until all its energy is transported. As mentioned earlier, common examples of mechanical waves are water waves, sound waves and seismic waves. There are three types of mechanical waves: transverse waves, longitudinal waves and surface waves. Transverse waves are mechanical waves where particles of the medium vibrate about their mean position perpendicular to the direction of the motion of the waves. For instance, when one end of the slinky is fixed and you move the other end to the left and right of the slinky instead of to and fro. Longitudinal waves are mechanical waves where the medium vibrates parallel to the direction of the wave. Such a wave consists of several compressions and rarefactions. The rarefaction is the farthest distance apart in the longitudinal wave, and the compression is the closest distance together. One example of longitudinal wave is sound. Surface waves are mechanical waves that travel along the surface or interface between two media. An example of a surface wave would be waves in a pool or in an ocean, lake or any other type of water body. Electromagnetic waves, on the other hand, are waves that move through a vacuum, as they don't require a medium or matter. In a vacuum, electromagnetic waves travel at the speed of light, commonly denoted as c. Electromagnetic waves can have different frequencies. Such waves are typically known by different names, as they have various sources and effects on matter. In order of increasing frequency and decreasing wavelength, the waves are as follows: radio waves, microwaves, infrared radiation, visible light, ultraviolet radiation, X-rays and gamma rays. These electromagnetic waves are emitted by electrically charged particles undergoing acceleration, and subsequently the waves can interact with other charged particles, thereby exerting a force on them. Bear in mind that electromagnetic waves transfer energy, momentum and angular momentum away from their source particle. and can impart those quantities to matter with which they can interact. Electromagnetic radiation thus refers to electromagnetic waves that are free to propagate themselves without the continuing influence of the moving charges that generated them. This is because they have achieved sufficient distance from those charges. Electromagnetic waves of visible or lower frequencies produce what is called non-ionizing radiation, because here the photons individually do not have enough energy to ionize atoms or molecules or break chemical bonds. The effects of such waves on chemical systems and living tissues are brought about mainly by heating effects from the combined energy transfer of many photons. But in the case of high frequency electromagnetic waves such as ultraviolet, X-rays and gamma rays, the resulting radiation is called ionizing radiation, where individual photons of such high frequency have enough energy to ionize molecules or break chemical bonds. These radiations have the ability to create chemical reactions and damage living cells in a way that goes beyond simple heating, and thus they can be treated as health hazards.